tunnel represents the tunneling of the network. Then VTP is the endpoint of the tunnel. Then V bypass representing some connectivity between the controllers. Right? Then also we have an interface, which is the representation of the endpoints. So interface can be a virtual machine, can be a physical server, or network appliance such as a load balancer or firewalls. Then these components will be connected using the virtual links, so which representing the physical connectivities between the interface. Then we have this kind of the model as a kind of the icon. Then you can allocate this component and connect to each other using the interface and virtual links. Then today's our hydrogen release, we provide this configuration as a command line or script, not in the graphical user interface yet. But the concept will be this model will enable you create your own logical networks by combining these components on your demand. Right? Then this is an example of how VTN will be created on the network. Then in the physical network layer, so we have a 3 domain or 3 data center. Then each data center or domain has its own controller representing this green triangles. Then these controller will manage the existing open flow switches, and then these 3 controller can have a single multi-tenant environment crossing the multiple domain and then crossing the multiple controllers. Then for example, in this domain A, we can have a 1 layer 3 and then 2 layer 2 domains. Then this data center 2 may have a single layer 2 domain, then which is connected to the data center 3 using the tunneling capability. Because we may have some non-SDN ready devices between the data centers, such as the optical node or transport networks. Then in this case, you can use a vTunnel to connect these 2 layer 2 domains. Then if you double click this vTunnel, you will see the both endpoint of the tunnel, then connected to the V bypass, which representing this non-open flow ready device. Then this endpoint will be the overlay gateways. Then by combining these components, you can create the single tenant crossing the multiple domain and controllers. Then I would like to show you the demo of this VTN in the second half. Right? Okay. Then based on this modeling, VTN provides several feature sets. Then first of all, you can provision the virtual networks. Then you can design them by VTN, then add, delete, or change the VTNs. Then you can also control each component of the model, such as a vBridge or vRouters. Then after provisioning the virtual network, you can control the flows on logical ways. Then first of all, you need to create the 12 tuple-based flow filters. Then define the actions, such as a forward, drop, redirect, or remarkings. Then if you use this capability for QoS, you can also specify your QoS policies, in order to enable the QoS capabilities. Then not only that, we also provide the network monitoring capabilities. So VTN can provide the traffic status, such as the number of the packet or number of the byte in the network. Then also we provide the failure status in the network. So link failure or node failure will be also provided using our VTN models. Then let me tell you more detail about how we define the actions. So if you create a VTN, so traffic or any packet flows come to this VTN. Then first of all, we define the filtering matching condition as a V filters. Then using the 12 tuples. Then if this traffic match to this condition, we can define an action as a forward. So this is a simple packet forwarding. Then go to the destination. Or if you want to drop this packet, then the action will be the drop. And also you can remark the packet. So this is a high priority traffic. So you want to mark the packet and then give the high priorities. Then as in the last, we can also define the redirect of the packet. So it doesn't straightly go to the destination, and then it's a kind of the waypoint and stop by any the endpoint and do get some process, then back to the destination. So this kind of the programmability of the action will be defined. Then this is a more detail of the how to redirect the packet. Then you can see that we have 2 virtual machines here, then 4 physical switches in the network. Then now these 2 virtual machines are talking to each other, as you can see the black line. Then if you want to redirect some of the flow between these 2 VM and to the network appliance, such as a firewall or a load balancer, in this case, you set up the policy, then define the action as a redirect. Then, for example, you want to redirect the HTTP traffic to the network appliance. Then only the such selected HTTP traffic goes through the network appliance, but other packet or flow directly communicated between the virtual machines. So this is one of the redirect model we can provide using the VTN. Then as a use case, we can provide a network service insertion or service chainings. And then again, we have servers here. Then today we have to allocate the network appliance in front of the server farms. Then we have a network, and then traffic from outside is accessing these servers. Then, however, based on the VTN's programmability, you can allocate a network appliance any place in the data center. Then our controller will periodically monitor this network status, then also set up the flows. Then using Northbound API, we can provide the traffic status to the applications. So this application can be any application running on top of the controllers. Then based on the traffic status, they can, this application can give some feedback to the controllers. Then this controller will set up such control to the redirect the flows using the open flow capabilities. So as in the previous slide, if you want to redirect some of the flows, then only the selected flow will go to the network appliance, then back to the servers. So this is one of the use cases we can provide using the VTN models. Right? Then our VTN have a Northbound API. Then you can access this model using the REST APIs. Then you can put, post, or delete to these virtual network resources with XML or JSON format. Then also this API allows you to access these VTN models from vBridge routers, endpoint of the tunnel, then tunnel itself, vBypass, and link and interface. Then also, in order to map the physical resource to the logical resource, there is a 3-way to mapping. There are 3 mappings. One is a port mapping, so depends on the switch's physical port. You can map the logical tenant to the physical ports. Then also VLAN can be another way to map the physical resources. Also MAC address of the host can be the one of the tenant of the group. Then this mapping will be allowed to the with the VTN. Then also you can specify the flow filters. Then also it provides a controller's status and physical topologies, and then link or port status. Then alarm status also available using APIs. Right? Then this is a basic concept of the VTN. Then let me show you how we worked in the OpenDaylight. Then this is a hydrogen release, just available today. Then we have the SDN controller here. Then VTN manager is part of this component. Then also we have a VTN coordinator, which is an application of the controllers. And also we use the OpenFlow plugin in the hydrogen then to access the OpenFlow switches. Then today's hydrogen release was presented as 1 million line of the code. Then this VTN code is almost 30% of the number of the line of the entire hydrogens. Right? Then this is more detail of the VTN project. So we have two components. One is a VTN coordinators. So it's again application of the controllers. Then also it enables you to manage the multiple OpenDaylight controllers. Then VTN manager was implemented as a OSGI bundle and then part of the OpenDaylight controllers. Then this also the VTN manager manipulates the OpenFlow messages such as a packet in, packet out, and flow mode. Then using this architecture, we can manage the OpenFlow switches with VTN APIs. By the way, I forgot to mention this hydrogen release have several editions. Then VTN is a part of the network virtualization edition. Right? Then also we have integrated with OpenStack with the VTN. Then you can see the OpenStack has a Neutron, and then ML2-based ODP plugin is available. Then in the OpenDaylight controller, we have OpenStack common services. Then under this OpenStack service, we have OpenDAV manager or VTN manager and OBS DBs. Then this VTN manager will automatically map to the OpenStack Neutron to the VTN models. So for example, the network will be mapped to the VTN, or support will be mapped to the vBridge interface, something like that. Right? Then also as a next step, we would like to have a VTN coordinators application on top of this site. Then this will be the next target of the hydrogen release. And also we are open to have more partners or project to use these VTN coordinators using our Noseband API. Okay, so now I'd like to switch to the live demo using this VTN with the OpenDaylight controllers.
Hello, I'm Hideki Tai from NEC Japan. Now I would like to begin the demonstration of VTN. In this demo, I'm going to so in this demo, I'm going to slice an OpenFlow network to 3 isolated virtual networks. I configure mappings between virtual interfaces and hosts. So hosts can communicate on virtual networks as I configure in the VTN model. So for this demo, I've deployed a VTN coordinator and 2 OpenDaylight controllers and 12 OpenFlow switches with hosts in our laboratory. So here we use Mininet to generate OpenFlow switches and hosts. So later, I am going to remotely access this environment to show how to create virtual networks. And I'm going to send requests to the VTN coordinator for virtual networks in the form of REST API. Okay. So when the VTN coordinator receives requests, it dispatches the request to OpenDaylight controllers. And then controllers create virtual networks and handle packet-in message and calculate flow entries and install them into switches. Okay, now. And in our environment, each OpenDaylight controller controls 6 OpenFlow switches. And on top of these, the VTN coordinator controls 2 OpenDaylight controllers. Okay, now let me start demo 1. In demo 1, I create 2 VTNs. And controllers are going to handle packet-in events and install flow entries into switches based on the VTN configuration. I'm going to create a VTN 1 for communication between host 1 and host 2. And VTN 2 for host 3 and host 4. So this slide shows the steps to create a VTN 1. To create an isolated virtual bridge for host 1 and host 2. First, I create a VTN. Second, create a virtual bridge in the VTN. Next, create 2 interfaces into the virtual bridge. Configure 2 port mappings on the interfaces. I'm going to associate the interfaces to switch ports connected with host 1 and host 2. Finally, I send packets from host 1 to host 2. So before create the VTN 1, let me send packets from host 1 to host 2. So this window shows the console of minute 1, in which 6 OpenFlow switches and hosts running. So here I can operate OpenFlow switch and hosts. And this window shows the console of minute 2. And this window shows the console for VTN coordinator. So now, host 1 send pin packets to host 2. But as you can see, all packets does not reach to host 2 because no flow entries are installed in the switches between host 1 and host 2. So, and now let me show you the GUI of controller 1. So now controller 1 detects several OpenFlow switches, but this controller does not detect a host yet. Okay, then, so this is a configuration command for VTN 1. So, and in this demo, I use curl commands to send requests to the VTN coordinator. So now I copy this command and paste these in the console for VTN coordinator. So now the packets from host 1 to host 2 are correctly forwarded. So again, the GUI of controller 1. So now, VTN Manager running in OpenDaylight controller detects two hosts and register this host information to other component in OpenDaylight controller, so we can see the host in this GUI, in GUI. So to forwarded packets, VTN Manager installs flow entries between these two hosts. So for example, so in switch 1, so there are two flow entries in this switch. So one is for forwarding packets to host 1, and another is for forwarding packets from host 1 to other switch. Okay, now next. So now I'm going to create a VTN 2 for communication between host 3 and host 4. So this is the configuration command for VTN 2. So before create, let me send packets from host 3. Host 3 send pin packets to host 4. But at that time, no flow entries between host 3 and the host 4 exist, so all packets drop. So create VTN 2, I copy this command and paste here. So now, as you can see, packets between host 3 and host 4 are forwarded correctly. And now, let me send packets from host 1 to host 4. Because the packet from host 1 does not reach to host 4. Because host 1 and host 4 are connected to different VTN. So in VTN model, each VTN is completely isolated. So host 1 cannot communicate to host 4. Okay, now demo 2. In the demo 2, I'm going to create a VTN spanning multiple controllers. So I create a VTN 3 for communication between host 5 and host 6. This slide shows the steps to create VTN 3. First, I create a VTN. Second, I'm going to create two virtual bridges. I create interfaces into the virtual bridge, and I create a boundary link to connect to two virtual bridges. Next, I configure port mappings on the interfaces. I'm going to associate the virtual interfaces to switch port connected to host 5 and host 6. Finally, I'm sending packets from host 5 to host 6. Okay, so this is configuration commands to create a VTN 3. So, for example, this first call command is So the first step I explained here. Now, for example, the second step to create two virtual bridges is these two lines. So we can descript the name of virtual bridge here. And OK, so first, before create the VTN 3, let me send packets from host 5 to host 6. So host 5 send pin packets to host 6. But no packets reach to host 6. So now I copy this command and paste these in the console for VTN coordinator. And I also copy these commands. Send request to the VTN coordinator. OK, now the packets between host 5 and host 6 are forwarded correctly. So that's all for me. Thank you. Any question to the VTN project?
One question. Are you planning to make this VTN coordinator functionality available in OpenStack? I mean, you showed that in the previous presentation that OpenStack is integrated with the VTN manager, but the VTN coordinator is not, as far as I understand it from your slide, integrated with OpenStack. Are you planning to make this functionality available in OpenStack?
Yes, so today's hydrogen release doesn't VTN coordinated and OpenStack coordinated, OpenStack integration. But we have a plan for integrate this. And actually, it's not in the OpenDaylight, but our product already supports the VTN coordinated application.
Beginning of the presentation, you mentioned that it's not an overlay design. So how do you enforce isolation?
So it depends on the, first of all, we define the flow using 12 bubbles. 12 bubbles from layer 1 port or layer 2 market ADA and then up to the layer 4 port. Then once you define the flow, you can define which flow belongs to which tenant. Then this tenant has an isolated channel. So depends on the first one, you take the flow that belong to which tenant, then you can isolate the flow.
But so in multi-tenancy, what about the addressing space? So are multiple tenants able to use the same addresses? So and then how can you distinguish between the flows?
Then in that case, when you define the tenant, you need to map the physical resource. In this case, you can define the physical port base or VLAN base or MAC address base. Then this mapping allows you to have a same IP address in the different tenant. Okay. Right. Okay. So if there are no more questions, then thank you very much for joining this session.